Hi, I'm Ted Cobfleisch. I'm an associate professor at the Department of Veterinary Science at the University of Kentucky, and I'm here to talk to you all today about how to use our website, EquineGenomics.uky.edu. This is a very simple page that we put together with the objective of making mapped high throughput sequence data sets available as easily as possible. So for those of us who've been working in the field of genetics and genomics for a while, what we do is we put together we generate FASTQ files, we map them to our genome of choice, and then when the study is over, we publish those data to the Sequence Read Archive or the European Nucleotide Archive. So what do those data look like? Well, they look something like this. Okay, so this is what the raw data looks like. What we would do when we downloaded it from either of those archives is map these data to our reference genome of choice, and then do visualize it using any number of tools or analyze them however it is that we had imagined. The thing is that if, for example, this is horse data, what we would do is we would map it to a horse genome. Well, somebody else has probably already done that. And what our repository is all about is being able to store those mapped data sets. By providing this repository, what that means is that people with perhaps limited means in terms of data storage or even ability with respect to being able to download a data set and map a data set. Those people are essentially frozen out of the use of these data. By making map data sets available to them, we can really improve the utility of the data. So how is it that we would use these data sets? Okay, so let's imagine a tool such as IGV, the Integrative Genomics Viewer. What we would need to do first in order to look at a genome in the context or look at our data in the context of a genome of our choice is we need to load a genome. Okay, so what's involved in building a genome for IGV anymore is creating a JSON file, a JavaScript object notation file, and these things can be kind of hairy to build. So we've done this for the horse, and essentially what you can do is you can click to load one of these genome files, genome JSON files from a URL, and we've provided that resource. And in order to load it into IGV, it's a relatively simple matter of copying the link and pasting the link. And then clicking OK, and then this file will be loaded by IGV, and you only need to do that once. So I've already done it, and it takes a couple of minutes, so we'll just skip that step. This genome that I've built for you all contains the annotations for both NCBI's RefSeq genes and the ensemble annotation. So both of those annotations are available to you, and you can click here to look at an expanded view of what each of these provides. And once you have that, great. I want to see what's going on in CXCL16. Perhaps I want to see how whole genome sequence data for a particular animal that I'm interested in maps to that. Okay, these are the FANG horses. That's the functional annotation of animal genomes horses that were generated by the equine FANG community. And we've got 2 thoroughbred mares and 2 thoroughbred stallions here. And what I'd like to do is I'd like to see just how well that data maps across this region to see if there are any assembly artifacts that might be tripping me up for variant discovery or something that's important to me. So for the file, mind you, all of the many of the applications that we use were written to read data from URLs. Nothing fancy that you need to do. Click on File, Load from URL, and so if you're doing this absolutely correctly, you will click here and you will copy the link and you will come over here and you will paste the link. But what's more fun, and this works on most operating systems, if it doesn't work on yours, you have to copy and paste. But hey, I can just drag, well, I can just drag and I can just drop. And I can click OK. You don't need to load the index in most cases. And what will happen is IGV will read from that URL, pull all of those reads back, and you can see just what your animal looks like across this locus. Now, this data set in whole is somewhere in the neighborhood of 40 gigabytes in size. We did not have to download the entirety of a 40 gigabyte data set. We did not have to map it to the equine reference genome. If all we were interested in looking at was what was going on at a couple of loci, what we can accomplish that in just a couple of seconds. Okay, so this is what the whole genome sequence data set looks like. We've stored, we have the mapped data sets for the four-fang horses. We also have RNA-seq data for these animals. And what I'd like to do is I'd like to see what, for example, the adrenal cortex looks like across this region. So again, we're going to load from the URL. We'll pull this up. The adrenal cortex, again, this is the AH1 horse. Drag, drop, load. And we can see just what, just how the RNA-seq reads map to this locus. All the exons seem pretty well represented here. And what I might like to do now is consider getting the reads from this locus to perhaps do a local reassembly of them or some other analysis of those data. So from the command line, SAM tools is an application that many of us who do this sort of thing use a great deal. It has a view application that you can point at BAM files in order to look at reads that reads in a SAM file. So yet once again, what I'm going to do is I'm going to take this URL, I'm going to bring it over here, and we can specify the coordinates that interest us. These for chromosome 11, a good idea to take out the commas. And what it will do is it will read that URL, it will read the index for that URL, and it will retrieve the reads that map to that region. For whatever it is you might need to pull down reads that map to a particular region, this is a very good tool for that sort of thing. Also, the UCSC genome browser. Let's go there. And obviously the something that is important for these tools, not so much for SAM tools, but for IGV and for the UCSC genome browser, is that the genome that you're looking at is the one that's being used by the tool. So for IGV, we built the .genome JSON file, but for the UCSC genome browser, what one would need to do, let's see, let's just go there, CXCL16. Here. And this is that region as viewed in the UCSC genome browser. We can click to add custom tracks. Once again, nothing fancy, drag, drop, and submit. So again, it's not going to upload the entirety of this file. It's going to get the index for the file and pick up specifically what you need. We'll click go. This is the file. It's all squished for us. We'll go down here and we will change the display to full instead of squished. And we can see just how all of the reads map to this locus. We'll squish them to make it a little neater. And there we go. So with this and with IGV, you can see exactly how your animal of interest lines up to a particular locus relatively easily. If you want to put data into our server, please give me a call. Again, I'm Ted Cobfleisch. I can be reached easily at ted.cobfleisch@uky.edu. If you want to get these files in whole, that is all 40 gigabytes of these BAM files, this probably, although you could use wget or some other tool like or curl in order to download the data from these URLs entirely, that's not what this is for. We are currently working to put together a Globus Globus endpoint on this server so that you'll be able to download the data asynchronously using that much more well-intentioned application. These URLs and this server can handle moving these smaller bits of data very, very easily, very, very quickly, but the larger bits aren't gonna work so well for it. That's how all of this works. And please don't hesitate to reach out to me if you have any questions.